In this lesson, we're going to look at how to separate substances using filtration. Now, we're going to take as an example this glass of dirty water. And this water has a number of different substances mixed in with it. We have, floating on the top, organic debris, bits of dead wood and leaves, for example. And at the bottom you'll see there is silt, which is a mixture of sand and clay. And also suspended in the water are millions of tiny little particles of silt and dead organic material, which have not dissolved but give the water this horrible dirty brown colour. Now, as well as these insoluble particles, there are also soluble substances present. These are called salts. Now, filtration is unable to remove the particles that are dissolved in the water, that are soluble in the water. It will only remove insoluble substances and organic debris, whether living, as in the case of these microorganisms, or dead. Now, we're going to have a look at various types of filters to see how they work. But first of all, let's just say this, that a filter will always allow to pass the solvent, in this case water, and substances that are dissolved in the water. So we can say dissolved substances or soluble substances. Those mean the same thing. And the filter will block insoluble materials or organic materials. So when we're choosing a filter, we need to decide what type of particle we want to remove from the solution. So, for example, a tea strainer, which has quite large holes in its grid, you can see this, it has a metal grid here with holes in, and that will be able to block small bits of organic debris, but it probably wouldn't be able to block bits of sand and silt. So the sand and silt would escape through the holes, and it certainly wouldn't be able to block any of these microorganisms here that you can also find in the water. So in order to block the bits of sand and clay and silt, for example, and smaller bits of organic debris, then we need to find a filter which has smaller holes. Now, a good example of a filter that can do this is filter paper. Okay, here's some, you see this is an example of filter paper. It's been folded into a cone shape. Okay, and if we pour this water in here, then we will certainly remove the bits of sand and clay. And if we have a look at a microscope image of this paper, we can see that it contains millions of tiny thin fibres which are crisscrossing all over the place, and there are little gaps through which, for example, the solvent, in this case, again water, and dissolved substances can pass through these gaps, but they are small enough to block pieces of sand. And probably, looking at these microorganisms here, it would probably be small enough to block, for example, this fellow here, which is called an amoeba. There, that's right, that's an amoeba. Okay, so these would not be able to get through the filter paper, but these other two organisms here, this is called a paramecium. Now, parameciums are quite a lot smaller than amoebas, and amoeba is typically about 100 microns in length, and that's 1/10 of a millimetre. Okay, so about 1/10 of a millimetre maximum. That would be blocked by the filter paper. If we were to impose that amoeba on this photograph here, it probably look, something like about that size, so it wouldn't get through. Now, the paramecium is about 5 times smaller than the amoeba, so let's put that to its correct size. Okay, something like about that. All right, now that possibly could get through your filter paper, right, which you don't want to happen. You don't want to be drinking parameciums. And this fellow here, which is called a bacteria, that's about 10 to 20 times smaller than the amoeba. So that's going to be really small. All right, and these can quite easily filter through our filter paper. Filter paper will block sand, clay and some microorganisms, but not all. There are other types of filters with even smaller holes in their mesh. These are called ceramic filters. Now, ceramic filters use ceramic materials, pretty much the same type of material from which flower pots are made, and you can see here this has got a kind of ceramic pot here, and that has within the walls millions of tiny little holes which will allow the solvent, again the water, to pass through, but will block even down to the tiniest microorganisms such as bacteria, which you certainly don't want to be drinking. Okay, so ceramic filters are very effective filters, but one thing that needs to be pointed out is that in choosing your filter you have to consider this, that the size of the holes affect the speed at which the filters work. So if you're using a filter with very small holes in it, then it's going to take a long time for the water to filter through. It's not really very practical if you have to filter large amounts of water, as you would do, for example, if you needed to clean water for large populations, such as villages or towns. In those cases, you've got to think of other ways of cleaning and filtering water that we will look at in another lesson.